Hey guys, I'm going to try and make this as quick as possible, but it's going to be a basic video on how to use the list and spreadsheet data and statistics document types on the Inspire to ease your series and uh, sequence graphing. So when you open the file, you'll see you've got columns listed by letter and rows listed by number. We've got this little equal thing. I'll show you that in another video. It's pretty useful, but for now we'll just do the basics. So the first row, I want that to be n. But just make sure you double up on your letters, because when you write one letter, say I do X here, like whenever I type X now in my calculator, if I enter that, it's going to think that I'm talking about this column of this spreadsheet. So I want to make sure that I make it clear that I'm just trying to make a title for my spreadsheet. So I don't want to say n, because anytime now, if I make this n, then anytime I type n anywhere, it'll think I'm talking about this spreadsheet. So I'm going to call that double n. This one I'm going to call an. This one I'm going to call SN for series. Okay, so our first n value we're going to call 1, because n 1. But now remember that the Inspire, the spreadsheet feature, is very similar to Google Sheets. So you can actually type, I want this to be equal to 2. I could just type 2, but to make things easy, I want to type A1, which is this is A, and it's at the 1, and I want to add 1. Now it's going to make a formula, and what we can do is we can hit Control and the Center key, and I'm just going to go to 10 on my computer here. And so look at that. We go all the way to 10, and now we have 10 numbers listed, just like that. I think that's a little easier than the 84. All right, A of n. So I'm going to use the example that we used in class. So I'm going to set this equal to. Remember to do the equal, because that's just the general way that you do this. So now, oops, not that. I want there. So I want 1 over 2 exponent, and not n. Yes, n, but it's not n. It's a1, because a1 is our n value for that particular point. And now we can do the same thing. Control Center, and we're going to do down to 10. And look at that. We get all our numbers. So now we can see that the sequence is approaching 0, because the top is 1 and the bottom is getting bigger. So now the series. The series is a little trickier, but it's not too bad. The first one is going to just be equal to B1, because B1, there's no sequences coming before, so you're not adding it to anything. But the second one, you're going to set equal to not B1, C1, because C1 is your first series, so the first sum, added to B2. The reason being is because the way that series is you're adding the current A of n value, so 1/4, you're adding that to the previous series value. That's how you get a series. And there you go, 3/4. Now we can Control Center and drag down. And there we go. Now, here's the thing. Sometimes it's hard to interpret the fractions, right? It's hard to tell, oh, is this approaching? Is it approaching 1? Is it approaching 2? Is it approaching 1/3? Is it approaching 2/3? So for this one, it's kind of obvious that it's approaching 1. But in the case that you might not know, I'm just going to make a fourth column called DEC for decimal. And we're going to approximate each series as a decimal. And the way that we can do this is type that the column equals C1. So the sum value is the same as the sum value, but we're going to multiply by 1.0. And what this does is it gives us a decimal approximation. The reason that it does that is because the Inspire, when you multiply by a decimal, so 1.0, it's going to be like, oh, now you want it in decimal, because previously you had a fraction, and now you want a decimal. So there you go. That is just another useful thing that you can do. And now it's very, very clear that this is approaching 1. See, we got we start at 1/2 and then we get all the way to 0.999 in only 10 n's. So there you go. Now to graph what we have here. You're going to make a new document, so you can do control doc, and we're going to add a data and statistics. So take a look. We've got this. These are all our points just randomly placed on a plot, right? But now we can organize them. We can make the axis whatever we want out of what we have here. So I'm going to do n in my x-axis, and I'm going to do a of n in my y. And look, we can see that it's approaching 0. It starts up here and it goes down here, and it's clearly approaching 0. Now I can make this a series as well, or decimal. Those are the same thing. It's just one's decimal, one's a fraction. I'm going to just pick one randomly. So for the series, we can see that it's approaching 1 as n gets larger. And sometimes it's going to be a little harder to see like where it's exactly approaching, but it should be clear that this is approaching 1, even, and we only have 10 n values. So imagine if we had 50, it'd be even more obvious. Now, that's pretty simple, pretty basic. I find this data and statistics function to be extremely useful because you can easily just click, now I want A of n. And there you go. Now I want S of n. And there you go. And that's just about as easy as it could get. On the TI-84, you have to say, I want L2 and L1. And then you have to click again, and I want L3 and L1. And then click again. It's just a little too complicated. This just seems like the easiest way to do things. It's just so much more simple, you know? So another thing that you can do with this feature is you can, for basic arithmetic, or for any arithmetic function, and for basic geometric functions, or basic geometric sequences and any arithmetic sequence, you can actually have your calculator predict what the function of the line that you're creating is. This example that I've picked from the classwork is actually basic enough that we can get a right answer. There are times, and I think Jacob showed me a function that he had that was just a little too advanced, that the calculator couldn't necessarily approximate perfectly what the value was. If you don't understand what I'm saying, like, I could explain to you in person, but all you really need to know is that the NSpire is meant to plot the points, but it's not going to give you a perfect equation when you ask for an equation of a really advanced problem. So what we're going to do to find the equation of our line, if we have an arithmetic or a basic geometric sequence, is we're going to go to Menu, Analyze, and we want the regression of our line. And look, we get all these options. For arithmetic sequences, it's going to be linear. You can also do the median value, like it'll show you the median value of the graph. You can do quadratic, which is squared, cubed, and to the 4th power, and then there's just general power functions, so that the calculator will do it for you. And but our function today is exponential. Now, if you didn't know the equation, you might not know that, but I promise there are ways to figure that out without knowing the actual equation. I'm not going to tell you them because you can look them up on your own time, but there are ways to do that. So I'm just going to give it away and tell you that it's an exponential, and I'm going to select that. And look, it gives us a regression line, and it even tells us the equation for that regression line. And sometimes when the line isn't completely accurate, it will actually tell you the R value or the R squared value. So it will tell you how accurate or inaccurate that line is. But this is perfect representation, so it doesn't show us the R value because it is 1. Now, 0.5 to the x, that doesn't sound like 1 over 2 to the n, right? Or to the x in this case. But it is, because 1 over 2 to the n, is the same as this, because 1.5 to the x is literally just 1 to the x over 2 to the x, and 1 to the x is always equal to 1. So therefore, this is the same equation, and the calculator just gave us the equation. So that's the basics on this unit, and I hope this helped. I will have a follow-up video.